Good day everyone, my name is Kao Mingjun from the Department of Electronic Engineering, and I will now present my poster. The title for my project is Eczema Lesion Segmentation using Deep Neural Network with models UNet, UNet++, and ResUNet++. So what is eczema? Eczema is a skin condition with symptoms that include red to brownish patches, itching, and pain. This project aims to solve the difficulty in segmenting skin lesions of eczema without the help of a specialist by developing a deep learning model for segmentation. By testing various UNet models, a maximum accuracy of 89.7% and die-score of 0.881 was achieved. The problem statements for this project include the need to create a fully automated system for segmentation to save time and avoid inter- and intra-rater variations. We also needed to further increase the accuracy from past works. This project aims to train a suitable deep learning model which is able to segment the eczema skin lesions and to evaluate the performance of segmentation done by the deep learning model. I will now move on to the methodology for this project. First, we separate the image dataset for training and testing, and then prepare the binary ground truth for the dataset. They represent the desired output that the model should acquire. We then preprocess the image dataset and perform image augmentation to increase the size of our dataset. Next, we build deep learning model and train it using the training set. We then perform image segmentation on the testing set using the trained model. We then compare the pixelized similarity of output images with their respective ground truths. Finally, we convert the segmentation performance of the model into readable data. The figure here shows the simplified workflow for this project. We first train our UNet model with the training images, and then we feed the testing images into the trained model for segmentation. Finally, the resultant images are compared with their respective ground truths. I will now discuss the results. Firstly, all modified versions of the UNet yielded better overall results compared to the traditional UNet. Next, pre-processing methods used on our image dataset, such as separating the RGB channels, ALC, and CLAHE yielded worse performance, with RGB green channel being the least worst. We also used various loss functions in conjunction with all of our models, and Tversky loss yielded good results for UNet++. Using larger kernel sizes or filter sizes increases the number of trainable parameters of the model, therefore increasing the time required to train it. Larger numbers of convolutional layers due to more sophisticated skip connections in UNet Plus and ResUNet++ also contributed to a longer computational time. The table here shows the comparison of the model used by this project with the model used in previous works, and we can see that the current model performs better in almost all cases. This table shows the performance of each of the four models, displaying their best results. Here you can see the traditional UNet was performing the worst, and the UNet with additional 2 layers was able to get the best results. In conclusion, by tuning and testing various parameters and UNet models, we were able to increase the segmentation accuracy from 88.24% to 89.7%. The model used was UNet with additional 2 layers, trained on image dataset, without pre-processing, and with 100 epochs. The learning decay rate used was exponential decay with a base of 0.9. The output segmentation map was also post-processed using morphological image processing. This model also had the highest die score in this project with 0.881. In conclusion, we were able to create a model that had better performance and accuracy from past works. Thank you.
Good day, my name is Chin Yun Tong from Department of Environmental Engineering, Faculty of Engineering and Green Technology. This video is about my FYP poster presentations titled Thermal Activated Persulfate Oxidations on Landfill Leachate. My supervisor is Dr. Bashir, co-supervisor Dr. Wong, and moderator Professor Nakayama. So, in summary, landfill remains as the most common municipal waste management in global. However, the productions of leachate associated with landfill persist as a major drawback, which bring harmful effects to the environment. characteristics of leachate change according to numerous factors, and it is essential to be studied to understand the biological process within the landfill and indicating the major pollutant to be used in leachate treatment design. In this project, treatment of leachate by using thermally activated persulfate oxidations was studied. Leachate collected from Sahom landfill, Perak, Malaysia. 3 operation parameters involve persulfate to COD ratio, temperature, and reaction time. While treatment efficiency review based on removal rate of COD and color. Experiment designed and optimized by using response surface methodology with center composite design and result analyzed by using ANOVA. For problem statement, characteristics of leachate influenced by various factors such as climate, precipitations, age, and compositions. Malaysia landfill leachate has high quantity due to precipitations, and food waste is the major compositions. Sahom landfill, which is the source of leachate used in experiment, operates since year 1992. It was an old landfill with stabilized leachates having low BOD to COD ratio with high recalcitrant organic compounds. Hence, it is suitable for chemophysical leachate treatment instead of conventional biological treatment. Advanced oxidation process, which is one of the chemophysical leachate treatments, are effective in treating toxic and recalcitrant organic compounds. Persulfate, which is one of the oxidants, has high oxidation potential and can activate to further generate even stronger oxidants such as sulfate radicals and hydroxide radicals. Activation methods such as high temperature, pH, UV light, or transition method. Thermal activation was popular due to its simplicity and promising treatment performance. There are 3 objectives in this research. First, to determine the characteristics of leachate from Sahom landfill. Second, to evaluate the performance of leachate treatment process using thermal activated persulfate oxidations. And third, to optimize the treatment process by RSM and ANOVA analysis. The main chemical used is sodium persulfate and main equipment stirring water bath filtering. This is the experiment run. First, 100 ml of leachate poured into 200 ml capacity Erlenmeyer flux. After adjusting pH and persulfate dosage, it will be covered with aluminum foil and put into the stirring water bath with lids and then set time and temperature. These are the results shown generated by using Design Expert version 10, the effect of operation parameter on COD removal efficiency and color removal efficiency. In a nutshell, as ratio, temperature, and time increase, the removal efficiency of COD and color increase. Strong synergistic effect was shown by the couple of ratio and temperature parameter. Persulfate dosage was a limiting factor for the treatment of leachate, since more persulfate will lead to more contaminants being oxidized. Temperature is a key factor in optimizing the treatment efficiency. A higher temperature provides more energy for the activations of persulfate by creating cleavage in the peroxide bond, thus generating strong oxidants, sulfate radicals. Process optimization by using RSM suggests the following optimum conditions: 10 persulfate to COD ratio, 18 degrees Celsius, and 120 minutes. Under these conditions, actual result obtained was 93.39% and 94% COD and color removal rate. Under these optimum conditions, the total operation cost per liter of leachate is 67 cents. Most of the costs come from electricity due to the high temperature and long reaction time. The leachate effluent meets Malaysia's standard discharge limit for COD and color. However, the low pH and high temperature require further treatment. Some of the recommendations provided are reducing reaction time with the use of sufficient persulfate dosage or with co-oxidants, or design integrated treatment system to reduce the operation cost and achieve complete treatment of leachate. That's the end of my video. Thank you for watching.
Good morning, everyone. I'm Mong Kai Ming. Today, I'm going to present to you my FYP research. The title of my FYP research is Effective Risk Management Plan of Residential Building Project during the construction stage in Ipoh. First of all, construction industry is one of the major industries in Malaysia which contributes to the economic growth and country development. However, it always hindered by different types of risks, including the cost overrun, time overrun, and poor workmanship, causing damages to the construction projects in terms of quality, reputation, financial, and workers' health and safety. However, the application of risk management in local construction industry is still low and not implemented. Based on the literature reviews, the previous case study showed that the current risk management of residential building project is not effective, especially during the construction stage. In this research, a risk management plan is developed for critical risks in residential building project during the construction stage. To solve the problem statement, the main aim of the project is to develop a risk management plan in a residential building project during the construction stage in Ipoh. There are several objectives carried out to achieve the main aim as following. The first objective is to identify the significant risks of residential building project during the construction stage in Ipoh. And the second objective is to investigate and evaluate the current risk management practices of residential building project during the construction stage in Ipoh. When it comes to the research methodology, triangulation method, which is mixed research method, is used for this research. Figure 1 shows the triangulation method. Next, the data collection method included in this research are the case study, semi-structured interview with focus group, and the analytical hierarchy process AHP expert survey. And figure 2 shows the analytical hierarchy process AHP expert survey form. And next, the data analysis method used is the analytical hierarchy process AHP expert choice, which is a computer software. Now, let's go to the result and discussion. The results in this research are obtained from the case study, AHP expert survey, and semi-structured interview with focus group. The selected case study is a 5-story staff quarter hostel block, which is a residential building project located in Ipoh, Malaysia. Figure 3 shows the 5-story staff quarter hostel block in Ipoh, Malaysia. Based on the results, 6 main construction risks and 15 sub-risks associated with them were identified and analyzed using AHP pairwise comparison as shown in Figure 4 below. Figure 4 shows an example of AHP pairwise comparison between the design change risk and poor quality of workmanship risk. Now, Figure 5 shows the overall AHP risk ranking of sub-risks, and based on the overall AHP analysis, the top 4 critical sub-risks are the client's satisfaction in changing requirements and design risk, which is under the design change risk. And the second risk is the health and safety risk, which is under the poor quality of workmanship risk. And the third risk is the budget changes risk, which is under the design change risk. And the last one, poor performance of workmanship risk, which is under the poor quality of workmanship risk. Next, the proposed risk management plan for selected critical sub-risks are portrayed in table below. Table 1 shows the critical sub-risks with their current risk management practices and proposed risk management plan. In conclusion, the aim and objective of this research are achieved. All the critical risks and sub-risks were identified. The proposed risk management plan is important to act as an effective guideline for all contractors and builders to refer to, especially during the construction stage. Now, last for the recommendation, in future, the research is proposed to be carried out in multiple case studies that are able to generate a systematic and comprehensive review model on risk management plan. That's all for my presentation.